So let's get started right away. We can skip this first slide real quick because Ewout mentioned it already in the introduction this morning. Just a few words about HL7 because there's a lot of confusion out there about what HL7 is and how it relates to FHIR. I often hear people saying that HL7 is the old standard whereas FHIR is the new standard, but that's basically a misunderstanding that comes from the fact that HL7 is a standardization organization that of course has a lot of products, and both the old HL7 V2 standard, which is often just called the HL7 standard, is just a product of that organization as much as FHIR is. If you are interested in joining HL7 and to also help developing these standards, the first step that you could take is to go to www.hl7.org and go to the Resources tab. And there you will find the so-called listservs. These listservs are basically email lists that you can subscribe to, and you will find a lot of there. There are more than 60 different working groups, all dedicated to one specific topic of healthcare. And if you're interested in what any one of those are doing and you want to join them, please subscribe to their email list so you will get invitations to their conference calls, you will know what they are discussing about, and you can right away start participating. So the mission of HL7 is to develop standards for healthcare, global standards, and enabling their adoption and implementation. And it's probably fair criticism to say that the enabling of the adoption and implementation has not been in the forefront of what HL7 was doing in the past, but that has very much changed with the introduction of FHIR. So looking at the history of HL7, you can see that this organization has been around for more than 30 years, and the HL7 version 2 standard, which is basically the de facto standard for data exchange in healthcare today, is dating back to the late 80s. So the standard that is the most frequently used standard worldwide for data communication in healthcare is older than the World Wide Web. So there have been efforts to renew the standard, to put it on a new technological basis, which eventually culminated in the publication of HL7 version 3 in the mid-2000s. But HL7 version 3 has had a couple of problems with adoption, mostly because implementers found it very hard to understand and difficult to implement. So FHIR is basically the latest product of that very same organization that has spent so much time developing standards for healthcare sector and has a lot of, there are many lessons learned along the way, a lot of experience gathered that eventually all has been poured into the development of FHIR. If someone around here has not done previous work with healthcare interoperability, this is what the HL7 version 2 standard looks like. This is a message that would be sent around between hospital systems to communicate patient data. And you can basically see that it's really not top-notch technology, what you see right here. It's basically just pipe-separated values that are being used to transport this data. HL7 version 3 is based on what we call the reference information model. That's basically an abstract model of all of healthcare. It's like the universal formula for everything in healthcare, and it's quite complicated. There's actually, I've heard someone say that there's only 5 people in the world who actually understood version 3. I'm not sure if that's correct, but I'm pretty sure that I'm not one of them. So most implementers will have found it pretty difficult to implement HL7 version 3. So the status quo that we are still struggling with today is that we have mostly version 2 based systems in the hospitals. So the EHR would send out messages, because version 2 is a message-based standard, to multiple subsystems in the same hospital. But of course, it's not the servers that need the information. It's eventually the end user and the end user application that wants to have data, information about patients and needs to submit patients back into the central EHR. But the communication between the subsystem server that receives the message and the end user application is mostly proprietary, because that's where the vendors have long since moved to web-based application, web-based communication, and also query-driven communication, because you wouldn't want to store information on the end user side. Instead, the end user application would just query any data that it would need on demand from its back-end server. So the paradigms have shifted in healthcare in the past decade, probably. We have moved away from desktop PCs in hospitals to mobile devices. We have moved away from static software suites to web-based, lightweight applications and apps. We have moved away from the organizational healthcare record to the lifelong patient-centric records. We have moved a lot of applications from on-premise deployment to the cloud. And we are now finding that in the past decades of digitization in healthcare, that we have a lot of digital information around, but we have mostly stored it in monolithic data silos where we can't retrieve the information for any meaningful way of interpreting it. Today, we would want to mine this information with big data algorithms, with machine learning, with AI, to gather new intelligence out of the information that we've gathered, but that's hardly possible because the systems that store this information are pretty much closed to the outside world. So these three guys, you've seen Ewout already doing the introduction. You will see the other ones, Graham Grieve, the product manager of FHIR, and Lloyd McKenzie. You will see them a lot around and giving talks all these days. So if you want to talk to someone who's really, really deep into the FHIR specification, feel free to talk to any one of these three guys, because they're basically the inventors of FHIR. And their idea was to say, okay, we need a new technology that supports this paradigm shift, that helps us to fulfill the needs that the software vendors have if they want to have web-based applications, if they want to use machine learning and AI and gather big data and whatnot. So their new vision was to have a primary system with an open API where end-user applications and third-party apps could directly query information, retrieve data, and also store back information. So that would not only enable end-user applications to web-based end-user applications to directly talk to the EHR, but we could also include mobile apps, cloud-based applications, or wearable devices. So the new beginning was to think, okay, how would we design a healthcare interoperability standard if we had to do it from scratch? Assuming that there was nothing around, how would we do it with everything that we have learned, everything that we know today about web-based technologies? So they were looking for success factors in modern communication platforms. And modern communications platforms that are very successful in integration are, for example, Twitter or Facebook. Integrating your own application with Twitter is super easy. If you tell your software guy to integrate your web shop with Twitter, he will say, yeah, no problem, and he will probably be done with it a few hours later. Because there's a well-documented API out there, he could just Google Twitter API and he will come right to the page where he has everything. He will find code snippets, he will find description of the data, he will find libraries that he could use, and he would also find a community of people who have done this before and where he could ask questions if he has any problems using the Twitter API. And that's basically the kind of success that they wanted to repeat in the healthcare industry. So they were looking at what the success factors were, but also decided to keep all the lessons learned, all the successful parts of the older version 2 of the older HL7 standards, and carry them into the new standard. So based on these insights, they developed an API, which today we know as FHIR. So here's a quick timeline of FHIR development. It started all in 2011, and we had a couple of publications that are called DSTU, which stands for Draft Standard for Trial Use. So quite early on, the standard was published in order for implementers to be able to use it and to test it, and especially to give feedback. So there were lots of connectathons where the specifiers and the implementers came together to figure out whether they were going in the right directions, whether the implementers were happy with the standard, whether they were okay with the documentation, whether it was readable, easy to understand, easy to implement. And in all these circles, there's always been feedback going back and forth between the implementers and the specifiers. So recently, in December last year, we've had the last release, which is now called R4 because it's the first normative version. It's no longer a draft standard for trial use. It's now a normative standard, but not all parts of the standards are normative. It's just the basic technology and a couple of common resources. So there will still be development in the FHIR standard, and there will be subsequent releases in about a rhythm of 12 to 18 months. So I think in the next room somewhere, Graham is just right at this time talking about the changes that will be made with the upcoming R5 release. So the FHIR acronym stands for Fast Healthcare Interoperability Resources. I'm sure you're all aware of that. But I think the acronym is really actually a genius invention because, well, first of all, the domain was still available, which is difficult nowadays. And also, if you type this acronym into Google, you will hardly get any false positive results. Everything that you will find when you type the acronym FHIR is relevant or pertains to the FHIR standard. So that's really, and also we have all these funny puns that we can make on the word, and yeah, it doesn't mean anything in any other language. So let's take a quick look at the FHIR manifesto. The FHIR manifesto are basically a bunch of rules that we try to stick to when we develop the FHIR standard. And the most important rule of all is to focus on the implementers. We are developing FHIR not for ourselves, not for specifiers. We are developing the standard for implementers. Implementers will always be the deciding factor of whether a standard will be successful, whether it will be adopted or not. So if we have a choice between making a beautiful solution for that specifiers are happy with, or making a practical solution that implementers are happy with, we will always lean towards the implementer. Also, there's this 80% rule, which says we are only going to standardize what is used in 80% of the cases. If there's something that is very specific to one domain in healthcare or very specific to one or more countries, it will not go into the core specification, and instead we will have to use extensions for that. And that's in order to keep the standard as simple as possible. We will always focus on reusing established web-based technologies, so not reinvent the wheel, but use technologies that are already out there, that implementers are already acquainted with, and that we can reuse existing libraries. We will also try to model the information that we transport as human-readable as possible, both for the end user, but also for the implementer. If you have seen an instance of a version 3 document or CDA document and compare that to the instance of a FHIR resource, you will find that it's, just by looking at the code, at the XML structure, it's way more readable that FHIR is way more readable than version 3 ever was. So The other part is there's a very big focus on the community. So supporting and developing the FHIR standard is most of all supporting and developing the FHIR community, because that's the biggest success factor that FHIR has. It's the people that implement it, the people that promote it, the people that help each other develop it, and then that give feedback to the specification. Last of all, we have a very big demand for scalability. The standard has to be very scalable because the healthcare realm basically is. We have very simple problems, like you're having a wearable device that measures a pulse and you need to store that information back into a cloud-based application. That's a very simple use case, and the solution should be very simple. But we also have highly complicated things like complex lab reports, whole patient records, diagnostic reports, genetic diagnostics and whatnot. So we need to be able to scale all the way. And of course, it has to be that the complex problems will also have complex solutions. As Graham often says, you can move complexity around, but you can't make it go away. But we have to be able to find simple solutions for simple problems as well. So what is this FHIR after all? It's basically a framework consisting of standardized but extendable building blocks. That's what we call our resources. And with these blocks, you can either build an information network by linking resources across systems, or you can move the resources themselves around and build a communication network. So in summary, what we have here is the API of healthcare. But also, I already mentioned, FHIR is a community. FHIR is a group of people, an ever-growing group of people who help each other out, who communicate with each other to make healthcare in general, and healthcare IT specifically, better. I want you to think, just for the scope of this introduction, think of FHIR a little bit like one of these Lego boxes, where you have all these different parts that you can use to basically build whatever you want. But what they also give you is these instruction guides that tell you how to build something specific. And that's a picture that I would like you to keep in mind for now. So if we open the box of FHIR, which is basically going to the first page of the specification, you can even see that it kind of looks like one of these Lego boxes with the compartments, and in these compartments you will find groups of similar parts that you can use to build something. In the foundation, you will find description on how to use the underlying technology, basically all the general information that you need to have before you get started. And on level 2, you will find implementer support. That's basically where you get the download links, where you find public test servers, where you find your libraries that you need. Then we have this security and privacy part where you can learn how to make secure applications, how to capture provenance, audit events, patient consent, etc. And then we have the conformance and terminology part, and that's basically the part that is giving you the tools that you need to write instruction guides. Instruction guides are really very important part of the FHIR specification. It's building the guides that tell other people how to build something, how to put together these different bricks and build something specific. Then we have the exchange part that's telling you how you can exchange, how you can move around these resources from one system to another. On level 3, we have the administrative resources. These are basically a bunch of resources that you will probably need regardless of what your specific use case is. You will probably always need a patient resource or a practitioner resource or an organization. On the 4th level, we have groups of resources that pertain to a specific use case, like clinical information, diagnostics, medication, workflow, financial, and more. On level 5, you will find a group of resources and a bunch of information that you could use to implement clinical reasoning based on a landscape where you already have all of your information, all your clinical information present through the FHIR API as FHIR resources. That's when you would want to, to extract measurements, to apply clinical knowledge to that data, or to extract information from your data, and that's what level 5 is guiding you to. So when you look at the list of resources that are available, the first thing that pops out is that some of these resources have this green box with an N in it behind them, and that basically means that these resources are normative. So these are part of the normative release 4, and if you use any of those resources, you can be pretty sure that there will be no changes anymore, at least no breaking changes in further releases. If you use any of the other resources, they will have a number behind them, which is called the maturity level. And that will basically tell you how stable these resources are. So having a low maturity level does not mean that you are not allowed to use it or that you shouldn't use it, but it basically means that you should get involved with the working group that is responsible for this resource, so that you will know ahead of time whether they are planning to make any changes, and so you can also contribute to modeling this resource in a way that it fits in with your use case. So please, if you use any resources that have a low maturity level, it's a very good idea to go in contact with the working group and help them develop the resources to be eventually also a normative resource. If you look at one specific resource, I've picked the most frequently used, the patient resource, you will get this tree view, which is basically showing you what's inside of these resources. So you get the different elements, you will see the data types and a short description of what this data element means. All of these elements are linked, so you can basically just follow the links if you want to have more information about a specific data type, more information about how to use a specific element, or if you want to follow the link in the short description that will refer you to a terminology like a value set that has all the values that you can use to populate this element. Here's what an instance of a patient could look like, for example. In FHIR leaves it open to you how to represent your data. XML is one option, but you could also use JSON, and there's also a bunch of other alternatives around. We commonly say that servers should support both XML and JSON, and if you are an app developer, a client developer, you can basically choose what kind of representation you prefer. So here's what a patient in XML would look like. In the blue box, we have what we call the narrative. That's basically a human-readable representation of the content of that resource. In this case, you can see it's just an HTML table. So if all interoperability would fail for some reason, at least we could take that part and display it to the end user, so he would have the full information that is contained in that resource. In the yellow box, we have an example for an extension. In this case, you can see there's a US element that is only used in the US and not in other countries. For example, where I come from in Germany, it's actually forbidden to capture the race of a patient, so we're not using that. And that's why it has been decided, because it's only used in the US, that this should go into extensions and not become a part of the core standard. And so in these if you're in the US where you have to capture that information, you could use this extension to add this information into the core patient resource. In the blue box, we have a couple of standard elements. These are basically the commonly agreed upon information that you need for a patient, like a name, an address, a gender, birth date, contact information, etc. So that's a nice example that you can see on how the 80% rule works. It says if a data element is most likely to be used in 80% of the cases. It will be part of the core specification. If not, it will have to go into the extension realm. So the purpose is to make the core resources as simple and as static as possible. Now let's take a quick look at a few exchange paradigms. So if you want to move your resources around, you have to try to transport them somehow. And there's a couple of different ways to do that. First of all, we have the REST paradigm. That's when you want to do web-based applications. That's probably your preferred way of transporting information. But we can also do messaging. Like if you're coming from the version 2 world where messaging was the de facto standard of transporting information, you could also do that with FHIR. Then we have the operations part, which basically allows you to use something similar to remote function calls to provide functionalities that other people can use by submitting parameters and then getting specific results back. You could also use or invent other ways to move FHIR resources around. As long as your content is a valid FHIR resource, it's absolutely fine to do that. And it would basically go into the services box, which is basically the everything else box as far as transport paradigms are concerned. But there's also in the middle, the storage part. That's not the original intention of FHIR to be a storage format for data, but a lot of developers have ended up using FHIR not only as a way to communicate their information, but also as a format to store their information, because it's very convenient. If you're starting from scratch developing a new application, why would you want to build your own database model and then map back and forth to FHIR when you can just store the FHIR resources the way they are in your back-end database? And there's a lot of databases out there that support that in quite a very performant way. So a lot of implementers are taking use of that, and that's how FHIR eventually also became a data model for data persistence. If you have never heard about REST, if you're not like the technical kind of guy, don't worry, everyone knows how REST works because we're doing it multiple times every day. Every time you open a web page in a browser, you're basically typing in the URL, which is a unique identifier for a specific resource on a server, and ask the server to return that resource to you. In this case, we are asking the hl7.org server to return the resource that is called index.html, and we will get an HTML file back, and our browser will display it to us. That's the same way that querying or asking a FHIR server for patient information works. If you want to ask, for example, one of our public test servers to give you the information for a patient with a specific URI, it will return the resource to you. And you can also, by using the header information, indicate whether you want the resource to be JSON or XML encoded. But quite often when we're browsing the net, we don't know the URI by heart, so we can just type it in. So we will have to search, and there's plenty of search engines out there. And what they basically do is they let you type your query parameters into a box and then encode it into the URL and send that query to the server. And the server will return a list of possible results that match with your query. And that's pretty much the same thing that's happening when you are querying for patient information on a FHIR server. Your keys will be encoded into the URL, will be sent to the server, and the server will return a list of patients that match your criteria. Of course, we would not want our end users to do it that way, to encode their queries into URLs and send them to servers and then look at XML encoded results. Of course, we would want that as a part of the back end of our very user-friendly application. So we will need to use that in our programming framework, whatever it is that you're developing in. And we have plenty of libraries out there that you can already use. We have the HAPI library, which is a library for Java developers. We have the .NET libraries. We have other libraries like for if you're an iOS developer or JavaScript, there's a lot out there, and there's plenty of talks that you can attend in these 3 days at the DevDays that will go in detail into any of these frameworks that you're interested in. So the question that you probably have in mind is whether FHIR is going to be the once and for all solution to interoperability, whether it's finally the one standard where you can just plug and play, plug two applications together and they will communicate. But unfortunately, that's not the case. That will never be the case if you have a standard that covers a breadth as wide as FHIR does, and that will be an international standard. There will always have to be, moving parts that you can adjust to your local requirements. And so in order to be, the expectation that FHIR would be out-of-the-box interoperability is basically like giving two kids a box of Lego bricks and ask them to build a house, and then expect to get two identical houses back. That's never going to happen unless you give those kids also a building instruction that tells them exactly how to connect these bricks to build a house. That's the way you could get two identical houses. And if they are not identical, you will be very exactly able to tell which of the kids made a mistake when building the house and where that mistake is, and you would be able to correct it. So these building instructions, these are the parts that give us interoperability. It's not so much the standard itself, it's just giving us the bricks that we can put together. So we need implementation guides. Whatever we do with FHIR, if you want to be interoperable, you have to use an implementation guides. And the nice thing about our implementation guides is they are basically magical. They can do wonderful things. They are both machine and human readable. They contain what we call profiles. These are basically instructions on how to use one specific resource in a specific context, like what are the minimum requirements, what are the cardinalities, what are the mandatory fields, which terminologies should you use. And you can use these profiles, which are also machine readable, to automatically generate code, to automatically adapt your UIs. They contain the information for not only syntactical interoperability, but also semantical interoperability. And these implementation guides and the artifacts therein are just resources like any other FHIR resource. So they can be exchanged and searched through the REST paradigm, just like anything else. So these implementation guides are basically putting the I into FHIR. That's what guarantees your interoperability. And in order to find an implementation guide, you could go to the implementation guide registry that will have a list of already pre-existing implementation guides. They are coming from multiple organizations. Some are from HL7. Some are from local HL7 affiliates, like, for example, HL7 Germany, or you can see HL7 Australia has published one right there. Or they may be coming from other organizations, like, for example, IHE. But what you can also do, you can create your own implementation guide. And there's, for example, a simplifier.net framework, which you can learn a lot about on these DevDays. That's the easiest way to basically get started and publish your own implementation guide. And that implementation guide could be a description on how other systems could connect to your server, like what profiles do you implement, what extensions do you use and understand, and what features of the specification does your server implement. So the most important part, however, if you want to get started using FHIR, is to join the community. Nobody has to figure it out all by themselves, and nobody ever should implement FHIR all by themselves. It's a community standard, so if you want to use that standard, please become a part of the community. And the easiest way to do that is to log into the FHIR chat. It's a Zulip chat on chat.fhir.org. It's free. You can sign up right now if you have your laptop in front of you and you haven't done it yet. Please do it right now and sign up to this chat. And you can find a whole bunch of different streams that are topic specific. So you should take your time to find out what streams are interesting to you, whether there are local streams. If you're from another country, there's a good chance that there may be streams that are specific to your domain, to your country. So please make sure to join that. And whenever you have a question, whenever you have a problem, if you don't know whether to go left or right with the specification, just ask the community. There's a whole bunch of nice people. You're not going to get the usual RTFM response if you have a question. So please feel free and have the courage to just get involved, to discuss with the community. So I would like to wish you a happy building experience through these Dev Days, and please take some time to look at the program that we have. There's a whole bunch of talks that are basically discussing particular already existing implementation guides. Right now in another room, there's Brian talking about the healthcare directory. For example, we have a talk later today about the International Patient Summary, which is also one of these guides. We do have a couple of guides for the US realm, which are coming from the Argonaut project. That will be discussed in multiple talks. And if you are interested in learning how to build your own implementation guide, you should look at the modeling track. There's a whole bunch of talks in the next days that are grouped into this modeling track where you will learn everything you need to know about creating profiles, about writing implementation guides, and how to publish them. If you're an implementer who's interested in using one of the existing libraries, like the .NET library, the Java framework, there will also be plenty of talks for these specific topics. And also we have a lot of information about other tools and frameworks that you can use, or rather reuse, so you can be a lot faster with developing your own application, because you don't have to start from scratch. Nobody has to start from scratch. That's what the community is there for. So please get all the information that you need and feel free to use and reuse what other people have already created. So if there are any questions, I'm happy to answer a few. I'm afraid we are a little bit over time still, but I'm sure I can take a couple of questions. And if not, just find me around in the next days and tap my shoulder, and I'm happy to answer any questions that you have. Thank you. Yes?
Are these slides available?
Yes, we will make all the slides available after the event. I guess it will probably take a couple of days, but you will receive an email with a link to where you can get all the slides for all the events. Yes?
The 80% solution that you mentioned.
Yes.
When it's a US core implementation, does that become part of, is it an extension even in the US then?
Yes, yes, extensions are always extensions. They will never be kind of merged into the standard unless the working group agrees that that's probably something that they've missed and that is very frequently used. It might become part of the standard. But as you mentioned, the US specific parts will always remain US extensions. And that's basically when you would look at one of these Argonaut implementation guides for the US realm, they will inform you and what extensions you should use or should make sure that you understand if you're implementing in the US realm. And there will be completely different extensions than, for example, in the German implementation guides, because we have other additional information that we use. So basically, the information that we would want to be understandable across the ocean, if we were to exchange data from Germany to the US, you would have the core elements that everyone can understand. We would all understand what the name, what the birth date, what the gender of the patient is, but maybe the German system wouldn't understand what the US Social Security number means, or what the the race extension is supposed to be, whereas in the US you would probably find a couple of German extensions that wouldn't make any sense to you just because they are not relevant. They are specific to the domain. So we could still exchange data, which is the core elements, and we can also, satisfy the domain-specific needs that we have to implement. Yeah. Yes?
We have a database for immunization and vaccine.
Yeah.
There are some columns that I couldn't find it. I couldn't find a corresponding columns in the FHIR description.
Yes.
So what do I do? Do I create an extension?
Usually, he's missing a couple of fields in the FHIR specification that he has in his immunization database, and he's asking what to do about it, whether to create your own extension. Creating your own extension should always be last resort. That's like if nothing else works, you create your own extension. But creating your own extensions, bear that in mind, means you're not interoperable with anyone unless other people start adopting your extension. So you're always better off using an extension that already exists because it has been published by an HR7 working group, maybe through the Argonaut project, if it's information that's specific to the US or something. So what you could do, if you go to the specification and look at like allergy intolerance, for example, there's a tab at the top that says Profiles and Extensions. And on this tab, you will find a list of already existing extensions. Maybe that's a place where you could find your answer. If not, please look at the community chat, whether there's a specific stream where people discuss about immunization and vaccines. I'm not sure if there is. It might be. If not, just go to the generic implementers chat, which is kind of the big bucket of everything, and just put your question out there. Describe what it is that you're missing, and just ask other people. And they will respond to you, and you will find who has knowledge in the specific sector or what working group is discussing, so that you will find the right people to discuss with. And maybe they will help you to create a new extension, which is then published through HL7, and that will in turn guarantee that you will be interoperable, because it's not your private little extension, it's the official HL7 extension that you helped make. So that should usually be the way to escalate to the bigger group of people and to find a community of people that have the same problem and will then later implement the same solution. And that's how interoperability works, basically.
I think that's a great path that I can take.
Yeah.
But in the meantime, if the company, they really need that data to see it,
Yes.
so can I start temporarily by creating an extension until I go through this whole process?
Yeah, well, you can always create your own extension. If your primary focus is not to be interoperable with others, but just need that information for your own purposes, feel free to create your own extension. It's just that if you want this extension to be interoperable, you have to go through the process. So, but you could create that own extension and use it for a while and then report to the community on whether that worked for you and what experience you made. That's the kind of stuff that helps, the development forward. If you can give them implementation experience on why, and if you can tell them why you made decisions the way you did and stuff like that. So that's basically helping the working group to move faster with that. Eventually, you may then have to change your extension a little bit. If the official extension comes out, it will have another canonical URL. It may have, if you're unlucky, a different data type. But other than that, you would just then have to basically move your implementation to the standard extension. Yes? I'm sorry, I didn't acoustically understand all of that. It's the adoption rate of FHIR in where?
The payer side.
On the payer side, oh, sorry. I assume you mean specifically the US payer side. I cannot answer that question because, as I mentioned, I'm not from the US, so I'm not that much involved in what's going on here. But I know that there's a talk about the Da Vinci project, which is kind of diving into that payer thing, as far as I know. And there's Viet. Viet is a guy that you should talk to because I think he's also doing the talk. So if you look at the program, look at specifically for the Da Vinci project. I think that's a place where you would want to go and where you find the people to ask that question. Yes?
So if you publish your own extension, does it have to get approved or can you start using it right away?
No, you can publish your own extension basically right away. Yeah. It's, the whole approval process is basically if you want your extension to be used by other people. Because, there's a fair use case for creating your own extensions and never talk to anyone about it, just put it out there as an FYI to other people. But if you don't have the expectance that other people would adopt your extension because it's just for your internal purposes, do whatever you want. Just, involve the community whenever you want this extension to be interoperable. Yes?
How are proprietary extensions differentiated from the interoperable ones?
Yeah. Every extension has a unique identifier, and this unique identifier is a URI. And if you create a new extension, you will have to give it a URI. Like it would be http blah whatever yourcompany.com/extension/my-extension, something like that. So, and if you have an official HL7 extension, it will always have an ID that comes from the HL7 domain. It will have hl7.org/something. Or for Germany, we'll have FHIR.de as a domain name for all the official German extensions. So whoever owns the domain owns the right to publish the extensions for that domain. So that's basically how you can tell, yeah. Yeah.
I found extension for the race. How would I know that extension is for the US and not for other countries?
Because it's published as a part of a US instruction guide, which is basically the US core implementation guide. And that's where this extension comes from. And you can also see it in the URL of the extension that it has this US-core-race in it. So it's... Yeah, that's a little bit weird because, the US does not have an HL7 affiliate organization. So everything that's published from the US is has the same domain name as HL7 International. So that's a little bit confusing. I agree with that. But for all the other publications, all the other affiliate organizations, they usually have their own domain. They have HL7.NL for the Netherlands or .de for Germany and stuff like that. So the US is pretty much the part that gets a little bit confusing. But I think they have somewhere in the path of the URL, you will find a /US somewhere in between. Yeah.
Just to see if I understood correctly, if I would do something like a DICOM private text, then it would be like an extension with my company's the URL, right?
A private tag in DICOM would be something that is specific to your organization only. Yeah, I think that would translate to FHIR as an extension where the URL is your domain /something. Yeah. Yes?
We use HL7v3, and then in HL7v3 there are some mandatory fields
Yeah.
that are not mandatory in FHIR
Yeah.
implementations. Are there any default values for that transformation, like from FHIR to HL7v3? And if it is mandatory in HL7v3, what should we pass in as default value so it meets the other standard and
Yeah.
the FHIR standard as well?
I cannot answer that question directly, but I think we have 1 or 2 talks about mapping V3 and transforming. So that's the people that you would like to ask. And we also have a dedicated stream in the chat for, CDA to FHIR, I think it's called, or something like that. So that's the place for you to ask. You're welcome. Okay, we're out of time. I have to go, but as mentioned, if you have any questions, just, come to me, ask me anything. I'm also in the chat. You can also send private message if you don't want to ask publicly. Just send me a private message through the chat. Thank you.